Hello, good day. Thank you for joining us today, being the tree of this program, Fundamentals of Machine Learning. You can do well by commenting your location and what your expectation for today. Yesterday we did linear regression. Today we'll complete that of yesterday. We'll fine-tune the model and also, if time permits, we'll look at logistic regression. So you can kindly share the stream to your friends, your colleagues, and even those that are professionals to come contribute their knowledge, to come and learn also. For no man is an island. I'll be glad to have them learning, and I'll also be glad to learn from them. Yesterday we were able to see linear regression, and we were able to first and foremost import our data sets. We also saw the different libraries, we explained them, and also we looked at the possibility or how to create a data frame using a list. So today I will show you how to create a data frame using a dictionary. If you don't know more about dictionaries, you can do well by visiting our previous tutorials on Python dictionaries, and you'll be able to learn how to make use of dictionaries. Before then, we'll just go through what we did yesterday. Line 1 shows us the importation or the bringing of those libraries. Well, here we imported NumPy, we imported pandas, we imported matplotlib, .pyplots. We also imported Seaborn. I told you that Seaborn and matplotlib is one out of, or two out of, the numerous Python visualization packages. In the second cell, we're able to create a data frame from 3 different lists. We created a data frame, and we found out that data frames can be created from a list. It can be created from different kinds of lists. Either the list is a numeric list, or the list is purely a string list, or if the list is a combination of both numeric and string. data types, we can do that. What you have on the screen is a combination of both numeric and string data type, and you see that we created a list. We created a data frame. Sorry, I'm trying to share the link across to enable some other persons get in contact with it. Okay, so after creating this data frame, I'll show you the way you can create a data frame from a dictionary. Let me just, first and foremost, let me clear all cell, all outputs. I'll clear all outputs. After clearing it, I'll now run it again, run cell 1. This cell 2 is how to create the data frame. Okay, so let me create a data frame. How to create a data frame from a dictionary. The Python dictionary is the mapping of key and values. So I'll call it studs. So the column name of the data frame comes as the key of the dictionary. Then the values come in a list form, which will be Anita, as I have here, Paul, and Paula. Good. Then I proceed to age. Then I have also 30, 29, 33. Then finally I proceed to country. Here I have London, Nigeria, and Turkey. Okay, so on this note, I can say df. Let me use df. Okay, df tools, df tools equal to pd dot data frame tools. Right, so that I can print my df underscore tools. Okay, let me see this. Df tools. It's good. You see, so whichever way you are comfortable with, you can whatever way you are comfortable with, you can use for the creation of your data frame. Okay, so That is just it. To create a data frame from dictionary, you can visit our tutorials on dictionary. Okay, I think I just have to run all these codes. I just have to run them. Okay, I have to take this away. Good. Okay, I've loaded the data, the data set, and this is just giving me the info. So remember, we'll start from where we stopped yesterday, how to remove the outliners. Because from our EDA, our visualization, we can see here that there's an outliner. You see an outliner, you see an outliner on both male and female as a result of the tip. So the tip values have outliners. Tip values have outliners. So when you check this, you also look at it, just viewing the tips, you see that this is, or these are the outliners. Okay, this is the 75th percentile, and this is the 25th percentile of what we call the first quartile and the third quartile. Good. Any values below the first quartile and above the third quartile is an outliner. So we use this, we first detect the outliner by using the quartile method, and I'm using the 75th, give me 75% and the 25% to determine the outliner. Then from this, I got that the highest value shouldn't be above 415 naira some fractions. Same with the lower value. Okay, so what I intend to do here, I'll apply maximum to create a new data frame, to see the data frame when the outliners have been taken away, both from the upper band and the lower band, when they have been taken away. Okay, so I have to make this new data frame, the data frame of the values without outliners. I have to make it a new data frame, which is this data underscore out. Okay, so I apply it that, okay, in the tip, in the old data frame, which is data, in the tip column, I'm applying I'm using numpy np.where the tip value is higher than the high value we got here. It should replace it with the high value. Where the it should also check where the tip value is lower than the low value we got as low. It should replace it as low. So we don't want any value higher than our upper band, and we don't want any value lower than our upper band. This all should be done in the tip column of the data frame named data. Okay, so when this is done, we try to see our new describe data.describe, and we'll find out that there are no outliners. Even if you look at if you look at the box plot, you see that there is no outliner. So now we have a clean data set, where we clean data set, which means we can, even when you view this, you find out that no outliners, which means we can create our model afresh with this new this new data frame, that doesn't have outliner. Okay, I will show you. Okay, let me quickly show you that of yesterday that had outliners, and you will observe that actually we've taken away those codes. Okay, before taking the look at it here above in cell 99, these had outliners, but now in cell 108, we've taken away the outliners, and we have a very clean box plot. Okay, so we'll be proceeding. Okay, so we'll import our train test splits. And remember, I told you that I'll show you how to calculate the baseline before you proceed, how you calculate the baseline. So I can do my vertical splitting first, X and Y. I've done that. Then also I have to perform my one-hot encoding by using pd.getDummies. So anywhere it sees a categorical value, it changes it to a numeric value using one-hot encoding. Okay, so you can, this is the result of the one-hot encoding. Then we can see the shape only increase the columns and not the observations. Okay, so perform our train test splits. And yesterday I told you sorry for that. Yesterday I told you the concept of this train test split. Today I'm not going to illustrate it. You can watch yesterday's video and you get it a better, you understand it better if you don't. But it uses the concept of packing and unpacking in Python. Okay, so I have my train test split. Now, before I import my logistic regression, I can check my baseline to see what I'm expecting to determine baseline for the model. So I can simply use the code baseline is equal to, we have Y train, that is the Y train dot the mean of Y train. This will give me the mean of Y train. I'll multiply by the length of Y minus, Y train. Good. So I can use this. Doing this, I can see my baseline. Okay, let's see baseline. What it will give me? It will give me a list. So let me view the first 5. So I can have this. You see, okay. So it expected that my model to give me this 314. This is the baseline. It should not perform below this. Okay. Yesterday taking a look at yesterday, our model performed in a very nasty way. So because we trained it with an outliner, you see this? Okay, so now I can get the mean absolute error of the baseline of my baseline is simply I've now imported the mean absolute error, so I can just import it here. Or let me check above. Did I import mean absolute error? No, so I can import mean absolute error and no need of okay, let me just import it from sklearn.metrics imports mean absolute error. Good. Then I have it at mean absolute error. Mean absolute error of the Y train using the Y train and the baseline. The Y train and the baseline. I can print it out. NAE. So I can do this. So this yesterday the mean absolute error of our model was this. Okay, so I guess you are seeing the differences now where we'll use a clean data to build our model. Okay, so we can proceed. We'll import this. I'll perform this. We'll initialize our model in line 120. Now we fit our model. We fit our model. After fitting the model, so that is one of the benefits of using a clean data to train our model. Our model will perform